Hello everyone. I once again welcome all of you in this series of video lectures. We have been studying thermodynamics and we have covered thermodynamics up till first law of thermodynamics, and we have studied sufficient theory in order to go for a tutorial class, and in this lecture we will be solving problems. So basically this is going to be a problem solving session. So based upon the concepts that we have built up so far, we will be solving certain easy preliminary problems. So let me quickly recapitulate the important points and important formulas that we'll be using in this problem solving session. So you must be very well be knowing the formulas for calculating work. Basically we have covered 5 kind of processes to calculate work, and you must know this. Eventually we will revise them while solving problems, but if you are not prepared with the theories that we have done, so either you must have listened to the lectures, previous lectures, or you must have studied thermodynamics by any other source if you are listening to this lecture and if you are planning to listen to this lecture any further. Otherwise you're not going to gain anything out of it. So make sure you know the thermodynamics up till first law of thermodynamics. So assuming, or it may be a very strong assumption, but still assuming that you know thermodynamics, at least you know the formulas, basic theory of thermodynamics, let us proceed with solving problems. So initially we'll be solving very trivial, primitive, easy problems, and later on we'll proceed to JEE level problems. Although JEE level problems are easy these days, but by JEE level problem I mean 1990s JEE level problem. So initially let's work on certain concepts that we have studied in the initial stage of the chapter. So I'm going to give you certain quantities and you have to tell me. So that will be constituting problem number 1 basically. So in this problem number 1 I'm going to give you certain quantities and you are going to tell me whether those quantities are state function or path function. So for the benefit of those who have forgotten what is state function and what is path function, state function is something whose value doesn't depend on state. That means if I bring my system to state A, it doesn't matter by which path I have brought my system to state A. And if it matters, if it depends on the path, that means it's not a state function, it's a path function. So the first quantity would be internal energy, represented by U. So U, or internal energy, would be state function or path function. So let me make the list first and then we will discuss them one by one. So in the meantime you think about it and get your answer prepared. State function, volume, heat, enthalpy. Although I haven't taught you enthalpy, so let's not talk about enthalpy now. Temperature. I'm sorry for my bad handwriting, but please bear with me. Work. Heat capacity. Let's talk about first these. Now you ponder upon them, you think about it, and then it would be good, it would be nice indeed if you pause the video and get your answer prepared. Now internal energy means every kind of energy that is within the system. It includes kinetic energy, it includes potential energy, it includes other vibrational energy that is in the system. So internal energy would be, if we talk about potential energy is by the virtue of force of attraction between two molecules. So if you have more number of molecules, you'll have more attraction. And if you're talking about state function and path function, then internal energy depends upon the state in which the system is. That means what is the temperature? Temperature is basically going to decide about vibration. The temperature is basically going to decide upon kinetic energy, and potential energy depends upon the force of attraction. But if we consider ideal gas, then ideal gas doesn't have any force of attraction between the molecules, so potential energy is not there. Basically ideal gas only have kinetic energy. That's why the energy of an ideal gas depends only on temperature. If we consider ideal gas, then internal energy is dependent only on temperature. Otherwise it would depend upon the stress in which the system is and other condition which is prevailing on the system as well. But anyhow, whatever the condition is, if that condition is unique, then the energy of the system is also going to be unique. No matter about the history, the past of the system doesn't matter. The path through which you have brought the system in that state, it does not matter. So internal energy definitely, no doubt, is state function. So this is state function. If we talk about volume, volume is volume, like volume is volume. So it doesn't mean, like if a vessel has, suppose a piston has 5 liter of volume, it does not matter how I have expanded my piston to 5 liter. 5 liter is 5 liter. So definitely volume is state function, not path function. Heat. Now heat is very interesting. Heat is a kind of energy which flows from one substance to another, and that flow is from a substance at higher temperature to a system or substance at lower temperature. Now heat can flow in different conditions. Heat can flow under isobaric condition, heat can flow under isochoric condition, heat can flow under isothermal condition, and different amount of heat will flow from one system to another system in different conditions, which we will see, which will have a greater feel of once we will solve a numerical problem on it. But for now you must have a feeling that suppose I have to do certain amount of work, and to carry on that certain amount of work, different amount of heat might be required. Suppose I have a system and I have to do certain amount of work, like I have pressure, volume. Now I have to go from A to B. Now from A to B I can go in various ways. I can go straight from A to B, I can go like this, I can go like this. So in each state the heat transferred from system, or heat given to the system, or heat ejected out from the system on going from A to B will be different in all the three cases. So if we talk about only state A and state B, so and when I change the state of my system from A to B, then the heat that would be exchanged by the system would be different. So the path which I am following to take my system from state A to state B, that decides, or rather that dictates, the heat that would be exchanged from the system. So heat is a path function. Now this idea would be more concretized once we will solve a numerical problem, but now you must have a prima facie feeling that heat is going to depend on the path you are going to follow. Suppose you have a adiabatic system and you are doing some work. Now in adiabatic system you must know, no, look, whatever theory we have covered, you must be very well acquainted by it. Otherwise this discussion is going to be a vain for you. You cannot take out full advantage out of it. You cannot have a leveraging advantage over this discussion if you don't know the theories. Now when I say adiabatic, something must be cleansed in your mind, that adiabatic means no heat loss, no heat exchange, dq will be 0. So you must know these basics we have covered, whichever. So either you go back and listen to the previous lectures, or you go back to the textbook and listen and study the theory up till the first law of thermodynamics. Whichever way you do, but you must know thermodynamics up till first law, then only listen to this lecture. Now suppose we have an adiabatic process, and now in adiabatic process dq is 0. So this is first law, du is equal to w plus q. Now in adiabatic process q is 0. So suppose I'm going from A to B. Now if I'm going from A to B through adiabatic process, then q is 0. Suppose this is not an adiabatic process, I'm going from A to B through a different process. Suppose I'm going through this path. So this path definitely is not adiabatic process. So in this path definitely dq is not going to be 0, and in turn Q is not going to be 0. So there will be some heat exchanged by the system if that is not an adiabatic process. In adiabatic process, Q is 0. If a process is not adiabatic process, Q is not 0. So in one of the process Q is 0, in one of the process Q is not 0. That means Q depends on the path. This is what I'm trying to make you feel. So Q is dependent on the path, so heat is a path function. So this much you must feel at least. Temperature. Temperature is temperature. Like if you have 100 degrees Celsius, it's 100 degrees Celsius. No matter how you have brought it, you have heated directly from 25 to 100, or you have heated in a step 25 to 35, 35 to 75, 75 to 85, 85 to 100. It doesn't matter on the path you have followed. Temperature is a state function. Work again, you will this one is easy. Work you understand. The path, if the path is longer, suppose you go from A to B like this, then the area under the curve will be bigger, so work done will be more. If you go from A to B like this, area under the curve is less, so the work done is less. Work definitely depends on the path, so work is a path function. Heat capacity, first of all you must know what is heat capacity. Heat capacity is the amount of heat given to the system to raise the temperature of the system by 1 degree Celsius. That is heat capacity. Now, to heat capacity will be higher if more amount of heat is required. Heat capacity will be lower if less amount of heat is required to raise the same system by 1 degree Celsius. Now in different path, different amount of heat will be required to raise the temperature of a system by 1 degree Celsius. So in different path, you will have different heat capacity. That's why we have CP, we have CV. CP is heat capacity at constant pressure. CV is heat capacity at constant volume. Both are different. Cp minus Cv for a system is equal to R. If you don't know this, don't bother yourself over this. We will see eventually as the chapter will progress. But Cp and Cv are two common heat capacities that we use, one at constant pressure, another at constant volume. So they depend. Heat capacity depends on the path you follow. So heat capacity will be a path function. I hope this much is clear up till now. If it is not, then you need not worry. You just keep on studying. Things will become clear eventually. So that was question number 1. We move on to question number 2. In question number 2, again I'll be giving you certain thermodynamic quantities, and this time you'll have to tell me whether those quantities are extensive or intensive. So again, for the benefit of those who have forgotten what is extensive and intensive, extensive quantity or extensive property are those which depends on the amount of substance which you have taken in your system. It will vary, like if you have taken 1 kg, if you change it to 2 kg, that property will change, and if it does not change, it is intensive property or intensive quantity, whatever. So let's begin. Again, I'll give you the list. Temperature, volume, pressure, density, viscosity, internal energy. Enthalpy we haven't studied yet, so we'll not talk about enthalpy or Gibbs free energy now. But pH. Let's think about these quantities or these properties up till now. By now. So what you do, you think about it, get your answer prepared before we start the discussion. Okay, temperature. Temperature, extensive, intensive. What? If temperature depends upon mass, then it is extensive. If temperature does not depend upon mass, then it is intensive. So does it depend on mass or it does not depend on mass? Suppose I have I have a container having water at 100 degrees Celsius. I take a spoon of water out. That spoon of water will be at 100 degrees Celsius. If I take a cup of water out, that cup of water will be at 100 degrees Celsius. If I take a bucket of water out, that bucket of water will be at 100 degrees Celsius. That means whatever amount I bring out, it does not matter. The temperature of the amount will always be 100 degrees Celsius. So temperature as such doesn't depend on what mass you are taking. So if it does not depend on the mass, it is intensive property. For intensive, I am writing in IN. It is not indium, it is intensive. Volume. Oh yes, volume. Volume, if I take a spoon of water out, if I take a cup of water out, if I take a bucket of water out, volume is going to change. So volume definitely depends on the mass you are taking. If you take 1 kg of sand or rice, if you take 2 kg, 10 kg, volume is always going to change. Volume will depend upon the amount you have taken. So volume is going to be extensive. Alright, pressure. Now this one is a little typical. No one is going to ask you, or in exam no one is going to ask you pressure is extensive or pressure is intensive, because suppose if I take water, suppose if I have a cup of water, then what is the pressure? Suppose if I have a cup of water, then what is the pressure at the surface? Pressure at the surface will be atmospheric pressure. Suppose this, I have a bigger container and you have a larger amount of water, then the pressure at the surface is still atmospheric pressure. If I go 1 meter deep, suppose this is large enough, or let's see if I go 1 inch deep here, and if I go 1 inch deep here, then the pressure at 1 inch deep in both the case will be the same, because from the knowledge of fluid mechanics you must be knowing pressure is dependent only upon the vertical height. It doesn't depend upon the broadness of the container. So the pressure in both the cases is going to be same. So pressure as such doesn't depend on the mass. So the amount which you have taken, that doesn't decide the pressure. Only the vertical height in case of fluid decide the pressure. So as such, pressure seems to be intensive because it is not depending on mass. But suppose if I have a closed container and if I have 1 kg of gas inside or 1 liter of gas inside, so 1 liter of gas will be exerting some pressure on the internal wall of this container. Then I put in 2 liter, or let's talk in terms of mole. Previously I had 1 mole of gas, now I have 2 mole of gas. So 2 mole of gas is going to exert more pressure. If I put in 4 mole of gas is going to exert still more pressure. So in this case, if I add more amount, that more amount is going to exert more pressure. So pressure in this case seems to be dependent on the amount. So pressure is definitely would be dependent on the amount of gas in this case. So as such, this is a typical case. I mean, I like to drop this discussion here itself. I'll not put pressure into any category depending upon the situation. Suppose if we have a situation like this, then pressure is intensive. It doesn't depend on the amount. If the situation is like this, if we have a closed container, inside we have gas, then the pressure would be extensive. That would depend on the amount. Okay, so if you have been given a situation, you can tell definitely whether in this case it would be extensive or intensive. Otherwise, in general, let's not give it a tag extensive or intensive. Okay, density is easy. If you take a drop of water from here, it will be 1 gram per centimeter cube. If you take a spoon of water, it is going to be 1 gram per centimeter cube. If you're going to take a bucket of water out of it, it's going to be 1 gram per centimeter cube. It's always going to be same. So definitely that's not dependent on the amount you have taken or the mass you have taken. So density is an intensive property. No doubt here. Viscosity is the ability or the tendency of a fluid to flow. If you take honey and if you pour that on the floor, that honey have very less tendency to flow unless the floor is very steep. If you take water, water will flow at a rapid space, much greater speed than honey. If you take jelly, jelly is kind of very dense fluid. If you take a jelly, kisan jam, and if you put it on a plate, then that is not going to move at all. It has very high viscosity. Honey has greater viscosity than jam, but water has even greater viscosity than honey. So viscosity is the ability of a liquid to flow. That is viscosity. Now, is viscosity extensive or intensive property? Then you see, viscosity is something which is intensive, like a tendency of water to flow would not be dependent on the mass you have spread over the floor, mass of water that you have spread over the floor. Water will always have a same tendency. It has something to do with the intermolecular forces in the fluid, and that will be the same no matter what amount you have taken. So tendency to flow will be same. It will not be dependent on the mass. So viscosity as such is intensive property, not depending on the amount you have taken. Internal energy. Internal energy definitely is going to depend on the amount you have taken. More molecules, more potential energy, more kinetic energy, more vibrational energy. So you will have more amount of energy from more amount. Suppose you have 1 kg of coal, then you can cook, or a woman in village can cook a food for one time. If we have 10 kg of coal, then you can extract more energy out of it. More mass, more energy. Definitely internal energy will be depending on mass. So internal energy is going to be extensive property, pH. Now pH is something that you know from class 10th. pH is negative logarithm of hydrogen ion concentration. Now pH depends upon the concentration and not the number or amount of mass of H+. Suppose you have a big tumbler. If you have a big tumbler having hydrogen at suppose 1 mole per liter, or the molarity is 1, and if we have a small tumbler and this is also have molarity 1, so like pH of both the solution is same because the concentration of hydrogen ion is same in both the case, although the number of hydrogen ion in this case will be much larger than this, but pH depends on the concentration and not on the amount. So if the concentration is same in two solution, then even though the number of hydrogen ion will be different in both the cases, but still pH will be the same. So pH does not depend upon the number of the amount of H+ ion, it depends upon the concentration of H+ ion. So pH is intensive property. This one is important. They may ask you in exam like IEEE or WBJE or PET level exam, anything. Suppose I add boiling point to the list, BP, MP, anything. So boiling point will be intensive or extensive. Now it would be clear enough. Boiling point will be intensive. Like if you heat any amount of water, it was always going to boil at 100 degrees Celsius. The amount of water that we take is immaterial. That's not going to change the boiling point unless the external pressure is not changing. So boiling point is intensive property. Boiling point is not going to change. I'll add one more quantity to the list, EMF. EMF is electromotive force. Now you are introduced to this term EMF in the chapter Electrochemistry, which is a chapter, one of the most important chapter in your JEE syllabus in physical chemistry. So probably you might have not studied the electrochemistry by now, but whenever we will study electrochemistry, we will always talk and we will always see or consider or discuss whether EMF is extensive or intensive. At that time I will prove it to you by the expression of EMF that EMF is intensive property. That means it doesn't depend on the mass. By now you must be satisfied by my answer. Explanation I'll provide you later in that chapter. But if at all you have studied electrochemistry and you're listening to this lecture, then you can make out, or at least you should try to make out, why EMF is intensive property. Now to make a feel, or to give you a feel, now I can tell you, suppose you have battery. You can have a smaller battery of 2.5 volt, you can have a battery of bigger size of 2.5 volt. Battery of bigger size will have more amount of chemical inside. That means the two batteries of 2.5 volt, although differ in size and differ in the amount of chemical inside, but still their EMF is same. EMF, EMF is same as voltage in ideal sense. So EMF is voltage. So voltage of the battery is same, although the amount of substance or the amount of chemical inside differs. That means it doesn't depend on the amount of chemical. So EMF or voltage of the battery or anything as such is intensive property, not extensive. So this is question number 2. I hope it's clear, and I hope you don't carry any doubt in your head. In case you do carry, then what you can do? What can you do? You can go back, study books, or you can contact us, mail us, and ask doubts.